Hello students, I hope you all are doing good. My name is Aviraj. Today we're going to solve the BPT 4. I'm going to explain the physics section of it. Without wasting time, let's get started. Now, first we will look the questions, thereafter we will look the explanation of it. Okay? Now, moving ahead, as you can see here, first question tells a body is dropped from a window, a train of a train. The time taken by the body to reach the ground in case 1 if the train is stationary, and in case 2 if the train moves with a constant velocity, and case 3 if the train moves with an acceleration. There are three cases: case 1, case 2, case 3. Case 1, train is stationary and we throw a ball from the window. Case 2, it is moving with constant velocity. Case 3, it is accelerating. Now, what it asks, the time of free fall is maximum when the train is stationary. Okay, the time of free fall is maximum when basically it is asking what the time of fall is, how much time the ball takes to fall to ground. We will look in different cases one by one. Now, moving to the explanation, as you can see, in case as you can see, when the case is stationary, means like train is stationary, simply our time of flight will be given by under root of 2h by g. Here g is fixed, h is fixed. Let's suppose its time is called as a t or t1, you can say, according to your convenience. Now, moving ahead, when the train moves constant velocity, when the train is moving with the constant velocity in this direction, let's suppose v, and the ball is falling vertical direction, so there is a no effect of this v along the vertical direction. No effect will be, so the time of flight will remain the same. Means the time of flight in the case of stationary train and moving with a constant velocity, there is no difference in the time of flight. But when the train starts accelerating, okay, then what will happen? Let's suppose our train is accelerating here with the velocity in this direction with the velocity of acceleration of a, and we have a g here. So net acceleration, what will be here? As you can see here, as the train is accelerating in the direction of horizontal, but the ball is falling. What ball is falling in the vertical direction? Okay, ball is falling in the vertical direction, so you can use the equation of motion as equal to what, ut plus half at square. You can apply in the direction of y, uyt plus half ay t square. Here you can see uy is 0 plus half ay is only g t square. Still the time remains the same. What it tells, it basically tells that the vertical direction is unaffected with the horizontal direction. If the train is moving in a vertical direction, horizontal direction, and if you are falling the ball in the horizontal direction, then what will happen? Then basically the time which is here, that is given by under root of 2h by g in the vertical direction. I am not telling about the horizontal direction. As the train is moving in horizontal direction and we are falling the ball in vertical direction. So even if you apply the, like, let's suppose even if you apply the pseudo force, you have a question in mind that we can apply the pseudo force. The pseudo force will apply in this direction and g will be there. So net acceleration will be in this direction. But if I ask you, see what in the time question, what is this g or a? It's a acceleration in the direction of motion of the ball. So even if you break the component in the direction of motion of the ball, it will just comes out to be g. There will be no contribution of a. Even if you solve it by pseudo force. What pseudo force do here? It's simply for the ball, there is in this direction there is a, and in this direction there is g. The resultant will be this. This is a net. But if you are applying the equation of motion in the y direction, then you just need to use the acceleration of the y direction. So if you just break the component in this direction, the component in the y direction will be only g. So the time period here will be also under root of 2h by g. So as you can see, the time period is unaffected by the motion of train, which is perpendicular to the motion of the ball. So what will be your correct answer? The time of free fall is same in all the three cases. So option 4 will be your correct answer. Now moving to the next question. It is, what is the nature of acceleration from t equals to 2 to t equals to 10 second? Okay, it's a displacement versus time graph, and t equals to 2 to t equals to what it is asking, up to 10 second only. Okay, it is asking about nature. Nature means what? You know, acceleration is given by d square x by dt square, or you can say dv by dt, means change in velocity. So we can easily understand by this graph, if the slope or the nature is positive, the acceleration will be positive. If the slope of velocity time graph or concavity of the displacement time graph is negative, acceleration will be negative. Now moving to the explanation. As you can see, for the parabolic nature of graph, acceleration is given by this. Okay. Now, for t equal to 2 seconds, we can calculate the acceleration. As the slope of the curve from t equal to 2 seconds to t equal to 10 seconds is positive. You can see the slope of the curve is positive. Therefore, acceleration will be positive. Because let's see, here it is 2 seconds and here it is 10 seconds, and it is like this. So when you draw the slope here, slope will be positive. If the slope will be positive, then our acceleration will be positive. So even if you draw this from the displacement time graph to the velocity time graph, the slope remains the positive. Hence the acceleration will be positive. So the nature of acceleration will be positive. Means option A is the correct option. Now moving to next question. What it tells, a body of mass m kg is taken up by an agent on the smooth inclined plane, okay, theta, with a constant acceleration of a meter per second square. The final velocity of body is this, the work done. Okay, it is just asking about the work done. Okay, you know, the work done can be easily calculated using the conventional rule of work done, that is force into displacement. Okay, so if the body is inclined plane, the plane of component g towards the motion is g sine theta. You know that in incline it is theta. So along this there will be only g sine theta acting on it. Okay. Now you can see when the body is moving with constant acceleration, then the total acceleration of the body while moving on the inclined plane is. If the body is also moving with a acceleration and there is a g sine theta, sorry, it is telling that it is taken up. Okay. Okay, it is taken up, saying now. Let's suppose we have an inclined plane like theta, and the body is this, and the body is taken up with the velocity this, and d sine theta is acting on it. Okay, if we sit on the body, its pseudo force will act in this direction, pseudo force will act in this direction, and then it will be g sine theta plus a. So your force will be m g sine theta plus a. Now you can put sine theta from here basically, which is mg sine theta up by a. Up now if the object travels, then we can write, when the object travels, what we can write, like v square equal to v square plus 2as. If the initial velocity is 0, let's suppose the body starts with initial velocity 0, so our displacement will be this. So if our displacement will be s equals to v square by 2a, so work done will come out to be force into displacement, that is this quantity. Now let's suppose here it is saying that sine theta is equals to 1 by x. So we have put at the place of sine theta 1 by x, then it becomes z by x. So this got to be our force, and this got to be our displacement. Now multiplying the force with the displacement will give you the work done. So the work done will come out to be this value. So as you can see, our fourth option is like here. Our fourth option, mv square by 2x into z plus xa, matches with the solution. This is the answer. In this, you simply need to calculate the net force. Thereafter, you just need to calculate the displacement. So we can predict the work done. Now moving ahead, a motorboat going downstream overtakes a floating object in water. 1 hour later, the motorboat turned back. If the speed of motorboat in still water is constant and flow velocity is also assumed constant, motorboat will again pass the floating object at the time t given by. It is asking about the time when the motorboat just again passes it. Okay, The motor boat just again what passes it. So now moving to the explanation of the question, as you can see, it's a very famous question actually. This type of question is also given in Erodo. Okay, it's a very famous question. From the reference frame of floating object, the object is at rest and the velocity of boat is v, which is the velocity of still water. Okay, so if the boat crosses the object and travels for 1 hour, then to return to that same point, it will take 1 more hour. Yeah, exactly. So it again meets the object to in total 2 hours. It's a theoretical explanation. You can see it's here it is boat and raft. It going in this way, then coming here in this way. Let me adjust this. Yeah. Now we can do the mathematical calculation here. Let the velocity of boat with respect to water be v, and the velocity of stream is u. So now the distance from A to P, which is from here to here. Okay, here to here. It's simply as the going in a downstream, so it is simply v plus u, and for the upstream P to B, which is in upstream, means minus v minus u. Now, if we subtract the distance AP minus PB, AP minus PB, it will give the this distance, and this distance will come out to be AM, which is A to M distance. That is this value. So your AM will come out to be this value, and putting the from another thing like putting this value, what is that? AM equals to V T minus T naught plus U T plus T naught, and this is from the calculation, and from the figure you can calculate it is downstream. So your velocity is V plus U, and it is multiplied by this time, that will be your distance. So this value is given by simply your figure, you can see from here. Now equating these two, you can get the t equals to t naught, which is equals to 1 hour. So total time will be t plus t naught, which is equals to the 2 hours. So your correct answer will be equal to 2 hours, means option second is your correct answer. Now moving to the next question. A particle moving in a uniform circular motion undergoes an angular displacement less than 360 degree. Okay, from a point P to Q. Okay, the angle between average velocity from P to Q and the velocity at Q is. Okay, let's see what it's asking. It is saying that a particle which is at P first goes to Q. The angle between it is theta, let's suppose. So if we draw the like line like this and make a triangle here, you can see this is R, this is our R. So if this angle, these sides are equal, these angles are equal, and these angles are equal from this perpendicular bisector, it will become as a theta by 2. Now with geometry, we can see that it's theta by 2, it's 90, it's 90 minus theta by 2, it's again your means like this will be simply your 90. So if it is equals to 90 minus theta by 2, then it will be simply equals to your theta by 2. Now what it is asking, basically it is asking the value of velocity at Q. It is asking the value of velocity at Q. Now moving ahead, let's suppose theta is equals to alpha. From the figure we can see PQ is the displacement. We can calculate the displacement easily by using the vector rule, like this is one vector, this is another vector, angle between vector is this. So under root a square plus b square plus 2ab cos theta or formula. By using this formula we get this value, and again this, and putting alpha here 1 plus cos theta, you know 1 plus cos theta is equals to 2 cos square theta by 2. You know now cos 2 theta is equals to what? Cos 2 theta equals to what? 2 cos square theta minus 1. From here you can say that cos 2 theta plus 1 equals to 2 cos square theta. Simply. So you can easily calculate it. 1 is equals to 2 cos theta square. So from here we write 2 cos square alpha by 2, because theta is taken to be alpha. So PQ will come out to be this value. Now we can calculate the time taken. Okay, to in PQ calculated as time equals to what? Time simply tells us your like displacement over there to the velocity. We know OQ is equals to OP. OQ, which is radius, yeah, we know this radius are equal for both, and angle OQP is x. Now it is using the linear pair equation x plus theta equals to 180. It is x. I told you that these two angles are equal. So they have taken it as a x, and this is alpha, which is equal to theta. So from here x will become out to be angle is 90 minus alpha by 2. So it becomes out to be 90 minus alpha by 2. Average velocity can ratio of the displacement by time taken. You know the ratio of displacement and you know the time taken. So average velocity along PQ. PQ is the displacement. The angle between the average velocity between PQ and the velocity at Q is 90 minus x equals to 90 minus x. We know the value of x, that is 90 minus alpha by 2. Putting its value, it will become out to be, no, this is wrongly written, it will simply come out to be plus alpha by 2. So this is the angle between the velocity, which is asking velocity at Q, and the average velocity between PQ. So simply your answer will come out to be alpha by 2, means option 4 is your correct answer. Moving ahead, a car is traveling with linear velocity v on a circular road of radius r. Okay, if it is increasing its speed at the rate of this, then the resultant acceleration. It is asking about the resultant. You know, if a body is moving in a circular path, and if it is having its tangential and centripetal both acceleration, then basically what happens, there is a net acceleration of it. You know, tangential acceleration is given a meter per second square, centripetal v square by r. Net can be calculated as the under root of AC square plus AT square. Putting the value of AC and AC, you get the value. So the correct answer is a complete theoretical question. Second option is your correct answer. Now moving ahead, it's again a work energy question. Question number 7. A block slides along a track from one level to higher level by moving through an intermediate valley. The track is the frictionless until the block reaches at the higher level. This is a frictional force which stops the block in a distance d. The block's initial speed is v and the higher level of coefficient of friction is mu. The height difference between the two levels. It is asking about the this h value. H it is asking basically. Now you just need to use the work energy theorem here. You know that the going to the explanation, let m be the mass of the block and v its initial speed, h be the height difference and d is the stopping distance. U be the coefficient of friction and g be the. It are basically given the information which is used in the like values of constant or something like variables. Now, when we apply the conservation energy, we know that applying from this point to this point simply. You know that the initial total energy is equals to final total energy. Initially, we have only kinetic energy. So, kinetic energy is equals to simply your potential energy plus the work done. Work energy theorem basically will be applying work done by friction. It's equals to mu mg. D is mgh and mg square r. From here, we can easily calculate the h. After doing calculation, we got out to be h is equals to v square by 2g minus mu d. So your correct option will be option number 1. It's simply your conservation of, or not actually the conservation of energy. It's basically your work energy theorem. Like it should not be written like conservation of energy. It should be like work energy theorem. Work energy theorem. It's like this, which is equals to work done by all forces equals to change in kinetic, because there is friction, so energy can't be conserved. Okay, so it's a work energy theorem basically. Now moving ahead to the next question. A rocket toy moves vertically up with a constant acceleration. This okay. After some time, its fuel gets exhausted and then falls under gravity. Okay. If the maximum height attained by the rocket is 120 meter, then the speed of rocket when the fuel is just exhausted. Okay. Basically, now moving to the explanation, as you know that during its extent time with the fuel, its motion is upward accelerated. Bilkul, it's correct. Has the slope of VT graph, and the slope of VT graph is positive during T1 time. Let's suppose from T1 time it is just accelerating upward, so slope is positive, and going downward its slope is negative in T2 time. Okay, then the slope is negative. The same is saying here. Now from the curve we can calculate the displacement, which is area under this graph. So once you calculate the area, it will be simply your velocity into, it's like area will be what? This triangle half into base into height. So height is this, base is this. So half into base is T1, height is V. So complete area is T1 plus T2, height is this simply. Now from here we can calculate T1 and T2. From here you can calculate acceleration. From here we can put the value of T1, and then from where here T1 is equals to what? A1 by V. T2 equals to what? A2 by V. Putting these two values here, we can get the value of V. Once we put the value of T1 and T2 here, and we know D, we get the value of V, which is equals to, as we can see here, the values are also given. Yeah, acceleration is given. Okay, no issue. Just we can put the value of acceleration here, which is A1, A2. So we can put the acceleration, and then we can calculate the value of velocity. That will come out to be 40 meter per second square. So you can just do this question by using graphical method. So correct answer will be option number first. Now moving ahead, two spheres of equal mass, one at rest with each other. So collision is absolutely elastic, but not central. Central means what? Here it is telling about it's not head-on collision. Okay. The angle between the velocity mass. It is asking about the angle between this. We can easily calculate by using the conservation of energy, and not all absolutely elastic if it is. So energy will be conserved, and the momentum is also always conserved in collision. So let's suppose like there is a mass m, it is at rest, one is moving with given velocity, and they after collision goes in this way, and making the angle theta 1 and theta 2 with the horizontal. Now we can easily calculate what. Let's suppose theta 1 is equals to theta and theta 2 equals to phi. Applying the momentum conservation, like initial momentum equal to final momentum, we can apply it in x direction. Then we can apply it is actually in x direction. Applied in x direction. Then it is applied in the y direction. Okay, so see, this is the final equation in y direction, and this is the final equation in x direction. Okay, so now we can do some mathematical calculation that is done here, squaring the equation 1 and 2, then adding them. We get this value. It's a completely theoretical thing. You can also remember the result which we get from here. Okay, it's a thing like we should remember. Now from conservation of kinetic energy, initial energy equals to final kinetic energy. This is our another equation. This is equation number 3, and this is the equation number 4. From here we can calculate as a cos theta plus phi equals to itna, and theta plus phi equals to 90 degrees. Means like they both go at a 90 degree. It's a very famous result. You should remember it. Okay. The angle between the final velocities must be. Okay. Basically here in the question, this theta plus phi has been called as a theta. So here it should be theta 1 always, so that there will be no confusion. Basically, the whole angle is called as theta in the question. So it will be 90 degrees. Here it is misinterpreted with the symbol. Don't write theta everywhere, because theta is asked in the question, and theta is representing the whole velocity. Or you can just put theta 1 or theta 2. It's the best thing. Just don't phi and anything. Just put one theta 1 and another theta 2. Do the calculation. You will get that theta 1 plus theta 2 is equals to 90 degrees, and which is equals to a theta. This is the total angle. This is the answer. Now moving ahead. In a ground to ground projectile, okay, the tangential acceleration at the topmost. Okay, it is asking about the topmost. It is simply zero. You know this. There is only velocity in this direction, no velocity in this direction, and the acceleration is always in the direction of vertical. Like not vertical, it's in this direction. There is a component of like this and this, but in the vertical, like in the topmost point, it's totally vertical. So no tangential acceleration. So the option will be your third. It's a complete theoretical question. Now moving ahead to next question. A particle moves, velocity is given, force is given, instantaneous path. You just need to solve for dot product of force and velocity. It's a simple question. Power is given by force dot velocity. Just do the dot product and calculate it. You will get the power is equals to 140 watt. So your correct answer will be 140. Option 4 will be your correct answer. Now moving to the next question. The maximum vertical distance through which a fully dressed astronaut can jump on Earth as a fully dressed, okay, is 0.5 meters. Estimate the maximum vertical distance through which it can jump on moon. Okay, it's a gravitational question. It is asking the distance, basically it can jump on the moon. As a mean density, okay, the mean density of moon is given that of Earth. Radius is also, relation of the radius is also given, which is 1/4 of that of Earth. It's a complete gravitational question and the acceleration due to gravity wala question. So we can just do it. We know that the gravitational acceleration on the planet is given by this gm by r square. Now mass is equals to what? Density into volume. You can do this. Density is this and volume is given by this. Now putting the values we get g in terms of density and g capital G things. Now we know that g is proportional to basically what, density into r. Now here box means g dash. Here we are asking what g dash equals to g by 6. And here g is a g at earth. So this is g at moon, means the acceleration with the gravity at moon. Now here on the moon we can easily calculate here. Here simply understand this box represents dash. Here there is a misprint actually. It represents like g dash, m dash, h dash, alpha dash, whatever it is, it represents the comma like dash. Okay. So potential energy in moon is equals to potential energy, or equating the things basically, because the energy is always conserved, like putting g dash equals h dash equals to g h is, using the relation you get h dash is equals to 6 into 0.5, which is equals to 3 meter. So h dash is the vertical jump that astronaut can make on the moon. So h dash will come out to be 3 meters. So the correct answer will be option number second. Don't confuse with the box is just representing the hyphen and the inverted comma. You can not inverted comma, it's just a dash at the top of the thing. Now moving ahead, what is saying, a wheel of radius r rolls half of the revolution. Okay, it will just move half. You can see half means what, this a point comes out to be top, its final position of a, its initial position, its final position, and b comes out to be this point. Okay, now what is asking, the displacement of point which is at height hr. Okay, it's just asking displacement here. Simply it's your you just need to calculate the horizontal. You can, the center velocity is vcum, you know this. Multiply with is c. You know vcum in fluid rolling is equals to what, omega r. It simply is equals to omega r, and put the omega r here, and then you have a radius capital R. Then just take the, it's a right angle triangle. You just need to calculate the means hypotenuse. Hypotenuse will come out to be simply your this value. So after calculating, your AA will come out to be R under root pi square plus 4. R under root pi square, with option number first is your correct answer. Okay, moving ahead. In a non-uniform circle, it's asking non-uniform circular motion. The acceleration of the particle is equal to the sum of the magnitude of tangential acceleration, because it is right. Two accelerations are parallel to each other. This is wrong. Adjacent is right, but reason is wrong. Basically, the two accelerations are parallel to each other. How it is parallel? Like tangential acceleration is in this direction, centripetal acceleration is in that direction, net acceleration is in this direction. So tangential acceleration and centripetal acceleration both can't be parallel. It's simple. Both can't be parallel. So your assertion is right, but your reason is wrong. What is written here? No, it is wrongly written. Assertion reason is not true. Though accelerations are not parallel. Okay. Don't read this solution. You know these accelerations are perpendicular to each other. Tangential in this direction, centripetal in this direction. Now moving ahead, the velocity of the particle moving in xy plane is given by this. Okay, x direction the velocity, y direction velocity is given. Sure, if you're asking about the path, you just need to calculate, solve x. X will come out to be some function of t. Then solve for y, which will come out to be function of t. Eliminate t from here in terms of x. Put t here, you get the relation between y and x. And y relation between y and x represent the path of the particle. The same is here. You get the relation in x. Simply is this. or you can say this is the final relation between x and t. Then you get the relation in x, y, or t. Now to eliminate t, you can just square this equation and sum. When you square this equation and sum, it will represent an ellipse. Ellipse is x square by a square plus y square by b square equals to 1. So here it is representing the ellipse. Now moving ahead, a ball is dropped from an aeroplane moving horizontally at constant when the air resistance is taken into consideration, not taken in, taken into consideration. The bomb falls exactly below the Earth's aeroplane, falls behind the aeroplane, falls Earth ahead of the aeroplane with the aeroplane. What will be the answer? You know, like when the aeroplane is, let's suppose this is aeroplane moving in direction and you fall like this, and air is blowing what? With respect to this aeroplane, air is blowing in this direction. So it will simply make the ball to fall this. Okay. And also like when the ball is dropped, it has some velocity in the like if it is moving in this direction. Okay. So the ball exactly below is like the it has that velocity when it comes out to be like this. It will just fall like this. Let's suppose, oh, wait. No, 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 no. Let's suppose if a ball is aeroplane moving, if the ball aeroplane is moving in this direction and you throw up what it said, you drop the ball. It will go like this. Okay, it will go like because it has initial velocity simply which is equals to this velocity. So it will go like this. But if there is no resistance, it will go like this. But when we count the horizontal velocity of bomb will decrease. Yeah, its bomb horizontal velocity will decrease because the wind is more blowing in this direction with respect to the aeroplane. So it exactly not. Okay, there is a suspicion on that. Okay, basically it depends. They go. Listen one thing. Okay, if the velocity that it is getting, like when we drop the ball, okay, and when we look, it depends. Okay, from where we are looking. Here it is, I think, missing. Okay, the frame of reference. If you are looking from the ground now, then we drop a ball, then drop follows a parabolic path. But if you are looking from the aeroplane's frame now, the ball will go exactly down. According to the question, I think according to the explanation also, if you take the aeroplane's frame and there is no resistance, ball will just go down. But if there is resistance, it will fall back. But when you look from the ground now, I am giving the explanation. Don't just remember the answer. Okay, just understand the explanation so that in exams you can think. And when you are in ground now, a ball first follows the parabolic path, and if the due to air resistance the horizontal velocity gets cancelled, it can fall exactly down. It depends on frame. According to current answer, they are taking the aeroplane frame. From aeroplane frame, the ball without air resistance just fall down. So with air resistance, it falls in this way, so lagging behind. So option second is correct. But again, I am saying it depends on the frame of reference. So don't remember this answer ever. So don't remember any answer. But yeah, be careful about this question. Now moving ahead, it's also a very famous question. A person traveling in a straight line moves with a constant velocity v1 for some distance, then v2 for some distance. Average velocity. Average velocity means total displacement upon total time. So it is moving with a constant velocity. This is this and this. You know that total average velocity is equals to total displacement by total time. Total displacement is 2x and total time is t1 plus t2. T1 you can put as a t1 is equals to what? Time velocity equals distance by time. Time equals to velocity by distance. Then velocity by distance and t2 equals to what? Sorry, velocity equals to distance by time. So the time equals to distance by velocity. Yeah, and t2 equals to distance by v2. Put t1 t2 here. Cancel x. It will come out to be your v like what it is asking. It is asking average velocity now. Average velocity will come out to be your 2x upon x by v1 plus x by v2. It simply come out to be 2v1 v2 by v1 plus v2. 2v1 v2 by v1 plus v2. And if you just remove 2 here, it's v1 What? It will come out to be V equals to 2 V1 V2 by V1 plus V2. If we just make 2 here, it will be this, and if we just do it, its reciprocal of it is V2 plus 1 by V1. It is like this. So V by 2 is equals to what? V by 2 is equals to 1 by V1 plus 1 by V2. 2 by V is equals to this. So it's just rearranging the option. It's nice. Nice. I like this question. People just think in this way. So first you need this question tells you not. You should look at the options. Your answer is correct. This answer is also correct. But look at the option. There is no such option. So you need to make this option answer according to the option. And the only option that you are getting by rearranging the things is option number 5. Is your correct option. Now moving ahead, if the spring is extended by X on a loading, the energy stored. Okay, this is asking about the energy stored. If the tension in the spring is this and K is the spring constant. Okay. Now you know the tension means what? Force it is telling. So tension is equals to Kx. From here you can go to the X. X is equals to what? T by K. You get the X, then your energy know half Kx square. Put the value of X equals to here. It will come out to be half K T square by K square means T square by 2K. So your correct option will be T square by 2K. Second option is your correct answer. It's a complete little bit of mathematical trick question. Now moving ahead, mark the correct statement. If the velocity and acceleration have opposite signs, the speed will increase. No. If the velocity is zero at instant, then acceleration of the particle will be zero. No. You can see in the extreme, if the at the extremum point velocity is zero but acceleration is not zero. If the velocity is zero in time interval, then acceleration is not equal to zero at any instant within the time interval. It is also not correct. A particle moves along x-axis. If it is in the x-axis coordinate, velocity have the opposite sign, then the particle will move towards n only. Yeah, exactly. Just suppose the displacement of particle is positive, but the velocity is negative. That means the particle is moving to going towards the origin. Still, it has a positive coordinate. So option 4 is only the correct option between these three. Now moving ahead to the option number 4, it means 20 question. Wind is blowing from south at this, but the cyclists appear the wind is blowing from east at this. The cyclists are the below. It's a simply rainwater problem, wind problem. It's a simple vector algebra, something like that. So first we need to understand it. Now moving to the explanation. Velocity of wind is this. South is this. North is this. East is this. West is this. Velocity of wind first is south. Means in this direction. Acha, it is saying that take east as I cap. So this is your I cap. So this is your I cap, then what? This is your J cap, then this is your J cap. If you're taking J cap, so the wind is in J cap, and now wind according to the cyclist, so it will be in this direction. So using the relative velocity formula, we can get the value of velocity of the cyclist, which will come out to be Vw with respect to ground minus Vw with respect to cyclist. That will come out to be 10 I cap plus 10 J cap. It's simply your option number 1. And you can understand in this way also. Simply you need to understand that like it is going first in this direction, then for cycling it is this. So net resultant will be this direction. You can use the relative acceleration or relative velocity formula here. The same concept works on the relative acceleration. Question number 21. A block of mass this moving in this direction constant speed, it is subjected to force. Force is variable here. Remember this. And kinetic energy. So you just need to calculate the work done, which is equals to change in kinetic energy. So kinetic energy initial at x equal to 20 meter. Kinetic energy final, which is x equal to 30 meter. Just calculate the kinetic energy through work. Work at x equal to 20, work at x equal to 30. Just calculate it. Use this integration formula. Calculate at x equal to this, x equal to that. You know kinetic energy final you get kinetic energy initial. Put the value here, you get the final kinetic energy. Then you get the initial kinetic energy. Then the subtract it. Achha, it is telling that it is moving with constant velocity. So the kinetic energy initial is fixed. So you just need to calculate the kinetic energy finally. You know now. Work done is equals to change in kinetic energy. So work done you can calculate by using force. Integration F dot ds. Change in kinetic energy final mass, kinetic energy initial. Kinetic energy initial, you know this. You can calculate the kinetic energy final. So after calculation, the correct answer will come out to be option number first, 475 joules. Now moving ahead, two bodies A and B of the same mass undergoes completely inelastic, it is saying. So energy is not conserved, keep in mind. Moves with the velocity v1, this moves with a rest. Okay, so it just got stick. Okay, inelastic in one dimensional coordinate. So you just need to calculate the ratio of v1, v2. Collision two bodies move together with a velocity v2. Okay, so simply applying the momentum conservation means like initial velocity, initial momentum equal to final momentum. Final momentum will be your m1 plus m2 into v2. Okay, so from here you can easily calculate the v2. V2 is called here v. They don't care the subscript or the variable. Just be careful here. They have wrongly written. It's v is equals to v2 here. Okay, putting the value of m1 m2 and then is m1 v1. So the v2 will come out to be this. V2 by v1 or v1 by v2 is equal to 2 by 1 means 2 ratio 1 means like option is again careful. It's asking v1 by v2. So it is calculating v1 by v2. So your correct option will 2 ratio 1. If it is asking v2 by v1, then it is 1 ratio 2. So option C will be then correct. Now option 4 is the correct answer. 23th number question. A particle moves along the wire. Path is given such a way that the x component of the velocity remains constant. Okay. It's like what dx by dt is constant. So you can just calculate the value of a here. It's like dy by dt is equals to what? A 2x dx by dt. So we can do here, okay. You can see here dx dy by dt equals to 2ax dx by dt. You know dx by dt is constant, put it as a u or some constant. So you get dy by dt equals to what? 2ax u. This is the value. Now what it is asking? The acceleration of the particle. Okay, it is asking the acceleration of the particle. You know, you can calculate by this d square y by dt square is equals to what? 2au dx by dt. Again it is u, the 2au square simply some simply to a u square. If u is simply representing the x direction velocity in the direction of what? J cap. Here only the j cap is mentioned because y represents the j cap generally, not always. Depends on the question. Now moving ahead to the next question. Boy try to cross a river, want to reach exactly the opposite. Okay, on the other bank, which is necessary relation between VB velocity of boy in still water and velocity of river. It's a completely theoretical question. There is a river is going in this direction, and the boy has this velocity, like a boy has velocity with respect to ground. So if the velocity of the boy should move in this direction so that it can reach in this exactly opposite, and the velocity of boy must be greater, so that if it is less than this, then it will just can't get cancelled out. Okay, because to just reach this point, you need to understand that the velocity should be little bit greater. Okay, so that it's this component just cancel out and only this component will remain the same. If the velocity will be just equal now, then this component will not get cancelled out and the boy will not reach exactly opposite. This is the explanation. So third option is the correct answer. You can also read the explanation from here. Now moving ahead, a projectile of mass m is projected with a velocity angle theta from horizontal. What is the work done by the gravity? It is asking the work done. It's a simple question. At time t naught. Okay. So the height of projectile is given by this. The work done is equals to force into displacement. Force is mg. Height is this. If it is asking as a height as what? A mass of the m is projected with angle velocity from the horizon. What is the work done by the gravity at t naught? First, we need to calculate the time. I think there is some mistake in the explanation because in time t naught, like first we need to give the value of time. I think there is some issue in this question because it is asking about the gravity in time t naught. Like if we don't know see how much this time t naught is, this should be mentioned na, ki how much is time, because according to that we can calculate the amount of displacement in its time. But here T naught is not mentioned, so don't consider this question. I think uh, they have not explanation. देखो, you can't solve the question by reading the explanation here. This is the wrong way now. If you are in exam, you just have the question. So by reading this question, you are not getting anything. Like by what time T naught? T naught. There is no mention. What is T naught? No information about T naught. So just take care of the question number 25. I will see what we can do it for further. But now question is incomplete. Incomplete. Okay. Now moving ahead to the next question. It happens sometimes typing error. They have not mentioned the time T naught. A particle of unit mass is moving along this. The velocity of the particle varies. The velocity is given by this. The acceleration of the particle is a function. It is just asking acceleration. So you know acceleration is what? It can be given as a v dv by dx. Just do differentiation and you get the acceleration. It's v dv by dx. Put the value of v here, and do the differentiation. You get acceleration will be equals to this. Your correct option will be option number second. It's a simple differentiation question. Moving ahead, with question number 27. If a lift coming from the 8th floor is just about to reach 4th floor and stop on the 4th floor, taking ground as origin, taking upward as a positive, which of the following is correct? X is positive, negative, negative, negative. Okay. If the lift is coming from the 8th floor, just about to reach 4th floor, this is 8th floor, this is 4th floor, stop over there, taking ground as origin, this is your origin, and taking upward is positive, positive. So velocity, it is coming downward. So velocity is negative, displacement is positive, velocity is negative, and acceleration is also negative because it is in this direction, below direction. Gravity is in the below direction now. Let's suppose it tells it stops. That means there should be an force to stop it. Okay. So what? Net velocity, net acceleration should be in the opposite direction. Means like they go. There is a acceleration due to gravity in down. But if its speed is decreasing, then there must be an acceleration in upward direction, which is decreasing this g, and goes to zero because it's just stop. If there is no force, then it won't stop. And if it is stopping, there should be an upward force. So the net acceleration is always in upward direction. So net acceleration is positive, net velocity is negative, and net displacement is positive if the origin is this. The correct option will be, I think, option third. Velocity displacement is positive, velocity is negative, and net, it is A is representing net acceleration. Remember this, it's not G, it's net. So option third will be your correct answer. Now moving ahead to your next question. A block of mass m is attached to a spring in the vertical plane as shown in the figure. If the initially spring is in the natural length, the maximum block range from the maximum extension it is a simple energy conservation. The block is initially at rest. You simply use to energy conservation. It's like initial energy equals to final energy. When the block at the maximum, it has the potential energy. So now mgx is equals to half k x square. Simply you just need to understand this, and from here natural length is, from here you can easily calculate the value of what x 2 mg by k. Means option first is your correct answer. You just need to use the energy conservation. It's nothing like more than that. Now moving to the next question. Yeah. A ball is thrown vertically upward. Okay, which is the following represents speed? It is asking what speed, not distance, or sorry, velocity. It is speed. Speed is always positive in magnitude. During the flight, if the air resistance was like the whole flight, it is asking what the speed. First, the speed will decrease, then the speed will increase. So both in positive. First, the speed will what, or the speed will decrease and then it will increase. But is the speed decreasing or increasing? Like what? In constant manner. Or the speed will decrease, then it will increase. All graph represent the speed will decrease and increase, but you need to understand it. It is asking for the speed time graph. So you know the displacement time graph of this is something like parabolic nature, parabolic in nature. Displacement time graph. The velocity time graph is what? Is a straight line, and the acceleration time graph is also a constant. So the correct answer will be here simply, which is your option number, I think third. Third is your correct answer, means like this option. Because it's asking a speed, not the velocity. And a speed time graph in a free fall or something like that, it represents a constant. So it is wrongly written here. Remember this. As you can see, the gravity on the bed due to the speed body decreases because this was just point. No, it's simply this. No, this is wrong. Third option is correct. The graph is a straight line. It is not parabolic. Okay, because the acceleration is constant now, so it can't be parabolic. So option is wrongly mentioned here. Now moving ahead to the next question. A body is projected at such an angle that the horizontal range is three times the greatest height. Okay, horizontal range is three times. Horizontal range is three times the greatest height h max. Just equate these two things. Make is theta. Range you know this. Range you know the formula. U square sine theta by g. Horizontal distance you know. R is equals to 3h. Put this value and get the value of what? Angle. Theta. Simply your theta will come out to 4 by 3. You know, remember the triangle. 37-degree triangle, 53-degree triangle. Base is like 3, 4, or 5. Wait. Base is bigger. Right. This is 3. Okay. So 10, okay, 4 by 3. This is 4. This is 3. So 1053 equals to 4 by 3. Yeah, base is bigger. So 53 degree. You can write nearly about equals to 53 degree. Now moving ahead. Question number 31. In the presence of air friction, if the ball is thrown vertically upward, the time of ascent is less than the time of descent. Okay. When you know there is a friction and you throw the ball. If you throw the ball upward direction, friction will act in downward direction. And if you throw the ball downward direction, friction will act in upward direction. Acceleration is always means like gravity acceleration is always in downward direction. So it is asking if the ball is thrown vertically upward. The time of ascent is less than the time of descent. It is telling about this. Force due to friction always acts opposite. Reason is correct. Now we need to think on the assertion. In the presence of if the ball is thrown vertically upward, the time of ascent is less than the time of descent. But the time it takes to reach the top is less than the time it takes to come to bottom. Okay. Okay. Here you need to understand it. Like here the you need to understand the because the time is calculated with what? Time is calculated by under root of 2h by a net in x direction. You need to understand that if the acceleration a net is more, t is less. If a net is less, t is more. So when it is going upward, force in this direction. This g is also in this direction. mg plus this. In this case, a net is more. If a net is more, t is less. But when it is going downward, mg is below, but force of viscosity or drag is opposite. A net is less, so time is more. So assertion is also correct, reason is also correct, and assertion is the explanation. Sorry, reason is the explanation of assertion. So option first is the correct answer. You can see the calculation. Don't worry. Now moving ahead. If a projectile is projected with a speed u, making an theta with horizontal, what is the speed in the direction of motion when it is theta with horizontal? Okay, you just need to understand, we calculate the velocity. You just use the similarity of horizontal component. Cos 2 theta, that is u cos 2 theta by this, and it when it is making angle theta, then the velocity will be same now. Like first this is u cos 2 theta, then v cos theta. Both will be equal. Both will be simply equal. Just equate it. Calculate v from here, and you know cos 2 theta. So just solve it to get the value. You just need to equate it, yeah. U cos 2 theta equal to v cos theta. You just need to calculate the v. So v is equals to what? U cos 2 theta by cos theta. Simple. This will be, this can be also the answer. And if you expand cos 2 theta, you get this answer. So your correct answer will be option number 2. This is also correct. Don't worry. But according to option, I said, go according to option. This is the thing. Question number 33. A person standing on the floor of elevator drops a coin. The coin reaches the floor in time t1. The elevator is at rest. T2. If the elevator is moving uniform, time will be same. If the elevator is moving with constant velocity, there is no change in the time. Time will remain the same. But if it is accelerating, because the time depends on g, net acceleration. And if it is moving with constant velocity, there will be no effect in the acceleration. And if there will be no effect in the net acceleration, then how can time will affect it? So time will remain the same. So option first is correct. Now moving ahead, the next question. That is your option number. That is your question number 34. Let's see. Force is given, mass is given, coordinates is given. It's simply r, force into dr. Dr can be calculated as a dx I cap plus dy j cap plus dz k cap. Force can be given x I cap y j cap. Just do the dot product and simply put the value of x or y. It's simple. Okay, here force is given in both the directions. Wrong. It's a wrong calculation. Wrong calculation. You need to understand it out. Like it can be done in this way. Work done is equals to what? F dot here. Let me do the calculation. Maybe it is right. Let's suppose. Let me check it because I have a confusion here. X I cap plus 2y j cap equal to dx I cap plus dy j cap. Doing it, excluding the integration, x dx plus 2y dy. Now x goes from 1 to 3 and it goes from 0 to 3. It will come out to be x square by 2, 1 to 3 plus 2 y square by 2, 0 to 3. Putting the value, it will come out to be 3, 9 by 2 minus 1 by 2 means 8, 4. Result will be 4. And from here, 9 by 2 into 2. 9, 4, 13. Answer is right. Oh, sorry. I didn't, sorry. Solution is also right. I didn't look the this thing now. Sorry. Solution is right actually. I didn't look on the next step. It's my mistake. Yes, they have done X in Y direction. No, solution is right. No. Answer is also right. Solution is also right. Okay, now moving ahead. The velocity versus time graph of a body shown in the figure. Velocity versus time. Its velocity is time. It's constant. It's constant. Now it is asking average speed. Okay, it's total distance upon total time. Total distance will be always positive and just add it and just put the time equal to 6 seconds. Total distance will be same. But it is asking average. You need to understand here. It is asking about the average distance. Sorry, average speed. So it is total distance upon total time. So distance is what? Distance is given by the area under the curve. So area under the curve will what? Area under the curve will simply you understand this like this is the first area, this is the second area, this is the third area. So you need to understand it that the This this area is what? 4 into 2. Then if it is asking distance, then in this also it is not subtracted. It takes some time. It has some velocity. So don't take it as a negative. They have done wrong here. It will be your 2 into 2 plus 2 into 2. It is 8 plus 4 plus 4. It's 16 meter per second. Be- actually, because they are asking the speed, so it is total distance. Okay, not total displacement. Displacement we need to subtract it out, but in the speed we do not need, because the speed means what? Total distance. Whenever the particle is moving, its distance is always positive. So in this area, the distance can't be negative. It is always positive. So the correct answer is one. They have done wrong. You can't take it negative. It's not average velocity. It's average distance. So it's average speed asking. Now moving ahead, angle between two vectors magnitude this is resultant. It's a simple formula based a square plus b square plus 2ab cos theta. Put a b r is 24, it's 12 18. You can calculate the theta. Just doing the calculation, you get theta is equals to, you can do these calculations easily. It's 75.52. Option 4 is the correct answer. I'm moving ahead. You just need to try to focus on what I am saying. Try to learn the concept. I'm not involving you in the calculation. You can do it by your own self. Otherwise, in exam, you how can you do? Try to learn the concept and analysis behind it. A cell is at rest at large height h. Okay. Sorts into two parts, which moves horizontally with speed this and this. It's a conservation of momentum. What time their instantaneous velocity are perpendicular. Okay, it's asking when their velocities are perpendicular. So you just need to understand it. First they are at rest, finally they are moving. So this is the relation between this. Okay. As they are rest to conserve momentum, they need to move in this way. So when there is a gravity, they will go like this. At some point, their velocity will be become perpendicular. Okay. We just need to calculate that time when their velocity becomes perpendicular. So you can do one thing. At any instant, write the velocity. So v equals to u plus at. V Q you know, K you know, T you know. Let's suppose at T time their velocity is perpendicular. V1 is perpendicular to V2. Write in a vector form. As you can see, V1 is here written here at time T and V2 is written here at time T. Do the perpendicular relation here and get a relation from here and get the time, which is equal to under root V1 V2 by T. You can also remember this. This is a very famous formula. You should remember it. It's a simple concept. Listen now. It is here explodes V1 in this direction, V2 in this direction. Okay, got it. Now at some time its horizontal velocity will not change, but vertical will change. Understood now? You can write V1 dash vector sometime, which is equals to U1 vector plus K1 vector into T. U1 vector, if it is writing it, you can write in I cap or like that. P1 I cap minus G P K cap. So the similar V2 you can write and then take dot product of it. Then calculate T. It will come out to be this value. Now moving ahead. A body of mass 5 kg has momentum this when the force is equal in the flat on the direction 10 seconds. What is the change in kinetic energy? Okay, it's a simple question. Momentum is given, body is given, velocity you can easily calculate simply, and you know initial kinetic energy. The work done, you know the work done, you can calculate the final kinetic energy. You know the force, you can calculate the acceleration. You can calculate the acceleration, then use V equals to U plus AT. You know acceleration, you know time, you know initial velocity by using momentum. By using momentum, you can calculate the initial velocity, then you know the acceleration, then you know the time, you can calculate the final velocity and hence kinetic energy. So correct answer will be option number 4. You can see the calculation. Try to learn the concept. They have done a very big calculation. No need to do this much. Train appears to move northward with a velocity not direction, moving in this direction. Man sitting in the car moving eastward. Man is moving in this. Velocity of car. Velocity of train with respect to ground. Okay. This is velocity of train with respect to car. And this is velocity of car with respect to ground. Now we are asking velocity of train with respect to ground. Velocity of train with respect to car is equals to velocity of train with respect to ground minus velocity of car with respect to ground. We know this. We need to calculate this. You know this. So velocity of train with respect to ground is equals to this plus this. Simple. Just do it and get the value. Direction you calculate using tan theta. It's simply north of east. So correct answer is 40 meter per second, 45 degree north of east. Sorry, angle is 60, so north of east. What is the correct option? Again, the boatman problem. A boat enters into water following, select the correct statement. We need to again understand this. It is moving in this action, so it has some velocity. There is one component this, one component this. The river component got cancelled, and then it is this. Boat must be reached B if it is taken an angle. It is okay. It's a simple thing. You need to understand it out. Okay. So to get exactly opposite now at B, we know that the horizontal component must cancel each other. So you just need to do this. This is the horizontal change, which must be zero. So just do the calculation, and you know, and you can follow, or you can. There is no issue. Yeah, you know, this is the velocity of water. Now the velocity of water must be equal to velocity of water must be equal to this is velocity of, just suppose, boat. Velocity of boat sine theta. Simple this equation. From here calculate cos theta. Simple. Option 4 is correct. It is given in sine. No issue. The displacement of a body may be zero when the distance traveled by it not to be zero. Now it's like where they go. You know distance is always greater than or equal to zero. If the displacement is zero, distance is zero. Distance is not zero. Distance can be bigger. Yeah, it is correct. Displacement larger, longer. No, it is wrong. Assumption is correct, but reason is wrong. Third option is correct answer. Three different mass deities are allowed to fall from rest from the same point along the different frictional paths. Speed of the three objects from reaching ground will be. Achha, different frictional path. It is asking about the speed. The speed, if it is moving in a different frictional path, then asking about the speed, you need to understand it out. If it is fall under the same height, so speed will be independent of the frictional path. So option second will be your correct answer. No need to worry. Because speed doesn't depend on the path. It depends on the vertical distance. Power versus position graph. Okay. Given. Particle mass is given. Initial or final position is given. Velocity or final position is asked. Now moving to the solution. Power velocity graph is given. It is in this way only. So this is the area under it from X. So what we are trying to, what we can like find here. What if it's asking velocity, we need to calculate the force. So power equals to force into velocity. From here you can easily calculate the force. There is no worry to about it. That force can be calculated as a mass into acceleration. Acceleration can be given as a mass velocity dv by dx. Simple. Just do the integration. X is 0 to 10. Velocity is 0 to, sorry, power is 0 to 4. You can calculate the velocity. You just need to calculate the velocity. It's a simple mathematical calculation. You just need to understand the concept. Power is what? Force into velocity. Now what you need to calculate? Power changes from where to where? From 2 to 4. Simple. Force is given by mass into acceleration is given by v dp by dx, and it is v square will become. Here the integration dx cross multiply. So p dx equals to m v square dv. Here integration will be what? 0 to, initially speed is 1. So 1 to v. Here integration initially it is 2, 4. Okay, let me look. Power is constant. Hai. Power changes. Power changes. Dx is here what? There's one thing. It's a power into area. It's simply P into dx. Okay. It's the trapezium area. You just need to calculate the area of this, which is the half into sum of parallel sides into distance between parallel sides. This is the left hand side, and right hand side you just need to integration and find v. After calculating, you get v equals to 4. So option, let's see what option is correct. First is correct. Now moving ahead, a particle moving in a circle radius r with a speed time takes to complete one. If the particle is projected with the same speed and angle with horizontal, maximum height attained by is equals to 4r, the angle of projection. It's a mix of two concepts. Okay. First is time period is given. You know, if a particle is moving in a constant speed in circular motion, time period is 2 pi r by v. So it's simply this is the velocity. With this velocity making an angle theta. So you know the u is equals to this, and the maximum height is this. Maximum height is given as a 4r. From here you need to calculate the theta just. It's again a mathematical manipulation question. So the correct answer will be option number first. First you know to calculate the velocity. Use the velocity in this equation. H max equals to 4r. Put the value of h max equals to u square sine theta by 2d and put here, and then calculate the sine theta. Whose theta? A lift with an open top is moving up with acceleration f. A body is thrown up with a speed u, lift respect to lift. It comes back to lift in time. The speed u is. Sorry, it asks its time. So you know the time of flight is affected by the vertical. What can I say? Vertical acceleration. It will be under root of what? 2h by g simply. Or in this time of flight, it put 2u sine 2u by g. It's like 2u sine theta by g, 2u y by g. Here simply your g is acceleration plus this z. So you can see here this will be your this. Now you need to calculate what? You need to calculate the u. U is equals to what? Simply your f plus g into t by 2. It's simply your f into g by 2. Its option third is your correct answer. Well, x is not given now, so you can't use this formula. Okay, this is the thing. That you need to calculate the h. So you need to use the time of flight formula. This is 2u sine theta by g. Whole time of flight is given now, so you can't use this formula. Yeah, I didn't firstly understand this. And it is given as a whole time, going up and down. It's the whole time of flight formula is given, used. Now, a neutron makes head-on collision with a stationary neutron. If the fractional change energy means the kinetic energy, sorry, it's elastic collision now. So kinetic energy initial minus kinetic energy final by kinetic energy initial. It is asking kinetic energy initial you need to calculate, final you need to calculate, then initial put the value and get the answer. You need to use the conservation of momentum and conservation of energy. Simply using the conservation of momentum energy, you get the velocities, and once you get the velocities, you can get the change in kinetic energy. You know the final velocity, you know the initial velocity is v, final velocity is v by 3. The initial velocity is v, final velocity is v by 3. You can get the initial kinetic energy, you can get the final kinetic energy, do the calculations and get the value, which is equals to 8 by 9. This is the fraction. If you ask percentage, then 8 by 9 into 100 will be the answer. So option number second is the correct answer. Now moving ahead, velocity displacement graph for a particle moving a straight line. So it's a velocity displacement graph. Okay. So acceleration it is asking. Acceleration you know v dv by dx. So just a dx is equals to v dv. Do integration. X varies from where to where. X varies from some point to some point, and v varies from where. Like it is also given. Sorry, slope is given. Okay, dv by dx is given. And then 10 meter. It is 0 to 10 meter is asking. Velocity is this point. It's like at this point velocity of acceleration is 0. So this is 0, this is 0. At 10, this point at 10, the velocity is 12. So just put limit 0 to 10 and then 0 to 12 root 3 and just calculate the find the acceleration. It's simple. Slope is also given here, dv1 over root 30. So once you use it, acceleration equals to v dv by dx. So dv by dx is given at that point, I'm saying. And v is given 12 root. Or you can do, oh yeah, you don't need to put integration. You can do, if the slope is given, you can do it in this way. 12 root 3 into dv by dx equals to 1 by root 3. So it will directly become 12. So 12 meter per second square is your answer. Third option is the correct answer. Moving ahead, a parrot flying due to east at the speed. Parrot is flying east. Okay. Train is 8 meter long traveling due to east at the okay. Both parrot and train are moving the same straight line. Train is 100 meters behind at zero view. Then how long it will take to overtake? It's a very famous question. So velocity of the train, just go to one frame and make that rest and then do the calculations of that. The velocity of train is like velocity of parrot with respect to velocity of train with respect to parrot. Just do this, which is equals to 515 minus 5, and then the initial distance is 100 meter or plus. In that time, train is that meter long. To overtake, it has to cover the train length also. The total distance will be this, which is equals to 400. So total distance is 400 meter. The velocity relative to the parrot is this. Now just you need to calculate equals to time equals to distance by 400 by 10. Then it equals to 40 seconds. So your answer will be 40 seconds converted into hour 1 by 90 hour. It's a simple relative velocity based question. Relative velocity makes this question easy. A body is allowed to slide down a physical surface track cleanly under gravity. The track ends in a vertical circular part in diameter d. What should be the height of this? Again, the energy conservation. Like here, falling from here and going to top here. So just apply the energy conservation. Simply, you just need to, you can apply from here to here or then here to here. 2 points you can apply the energy conservation. Now looking at the solution, for a body to reach at the point B, we know by circular motion, there here the velocity should be under root of 5 gr. This should be the velocity. You know the kinetic energy here. You know the kinetic energy here. You know the potential. You can easily calculate the potential energy from kinetic energy. Simply this potential energy converted into this kinetic energy. Okay. So mgh is equals to half m this v square. Put calculate h from here. That will come out to 5d by 4. So option second will be your correct answer. Now moving to the last question. Horizontal bridge is built across a river. Okay. A student is standing on the bridge through the small vertical wall upward with the velocity this. The ball strikes the water surface at 4 seconds. The height of the bridge above the water. Okay. Let's suppose this is water and this is bridge. The ball goes and takes total 4 seconds. So what it is asking, vertically upward, it stalls with 4 meter per second. You just need to calculate this height. So first calculate the time of flight. This will be 2 sine theta by g, which is equals to 2 into 4 by 10, that is 8 by 10. So it will be 0.8 seconds. This time is 0.8 seconds. Then this time is 4 minus 0.8 is 3.2 seconds. So if its velocity is 4 meter per second below, this distance is 3.2. Just calculate the height. S equal to ut plus half it square. You know the time, you know the initial velocity, you know the acceleration. You can calculate the S. Once you do the calculation, it will come out to be 64 meter. I have explained you the question. Here the solution may be different, but you need to understand it. You can do in this way also. So in this way, if you understand or solve the 50 question, the main focus of yourself must be is that to understand the analysis and concept behind it. Don't remember the solutions or something like that, or don't too much concerned about the calculation of it. Because at the exam you need to do calculation by your own self, so you must be good at calculation. So you just need to understand the basics or understanding behind it. So I hope you have understood. If you have any issue, you can comment it. I will try to explain it. Thank you very much.